Have you ever wondered how submarines work? Let's embark on a journey to explore the fascinating world of these underwater vessels. Submarines, known for their stealth and versatility, serve many purposes. They play vital roles in scientific research, warfare, and even in deep-sea rescue missions. The structure of a submarine is divided into several compartments, each with a specific function. The command center, the heart of the submarine, houses the navigation and communication systems. Then, we have the crew quarters, the living area for those on board. Next, we find the engine room, the power hub that propels the vessel through the water. And finally, we have storage compartments, which carry everything from food supplies to torpedoes. These compartments work together, ensuring the submarine operates smoothly and safely, even in the harshest underwater conditions. Now that we have a basic understanding of what a submarine is, let's dive deeper into its working. At the heart of a submarine's ability to dive and resurface are the principles of buoyancy and the use of ballast tanks. Let's unravel the mystery behind buoyancy first. In the simplest of terms, buoyancy is the force exerted on an object submerged in a fluid, be it a solid or a gas. Picture a rubber duck bobbing on the water in your bathtub. The water pushes up on the duck with a force equal to the weight of the water displaced by the duck. This upward force is buoyancy. If the duck's weight is less than the buoyant force, it floats. If it's more, it sinks. Now, apply this principle to a colossal structure like a submarine. The submarine, much like the rubber duck, displaces a certain amount of water, which in turn exerts a buoyant force. But unlike our rubber duck, a submarine needs to both float and sink on command. Here's where the ingenious design of ballast tanks comes in. Ballast tanks are special compartments within the submarine that can be filled or emptied of water. When the submarine needs to dive, the tanks are filled with water. This increases the submarine's weight, making it heavier than the buoyant force pushing up, causing it to sink. But what about when a submarine needs to resurface? It's quite simple, really. The water in the ballast tanks is replaced with air, making the submarine lighter than the water it displaces. The buoyant force then pushes the submarine upward and it resurfaces. To maintain a certain depth, the submarine balances the amount of water and air in the ballast tanks so that its overall weight equals the buoyant force. This state of equilibrium allows the submarine to hover at a desired depth, a technique often used during stealth missions or scientific exploration. So, by managing the amount of water in the ballast tanks, a submarine can dive, resurface, or maintain a certain depth. This delicate dance with water and air, buoyancy and weight, is what gives a submarine its remarkable undersea prowess. A submarine needs a powerful and reliable system to move underwater. That's where the propulsion system comes in. Now, there are two main types of propulsion systems used in submarines: diesel-electric and nuclear. Let's dive into how each one works. First up, diesel-electric. This system uses diesel engines to generate electricity. The electricity then powers the electric motors, which in turn drive the propellers. When the submarine is on the surface or near it, the diesel engines draw in air to operate. But when the submarine dives, the engines shut down and the submarine runs on battery power. This switch to battery power makes the submarine virtually silent, a big advantage when you're trying to stay undetected underwater. However, the batteries have a limited charge, so the submarine will need to surface or use a snorkel to recharge them. On the other hand, we have nuclear propulsion. This system uses a nuclear reactor to heat water into steam. The steam drives the turbines, which then power the electric generators. Unlike the diesel-electric system, the nuclear system doesn't need air to operate. This means a nuclear submarine can stay submerged for months, limited only by the crew's food supply. Plus, it's incredibly fast, but it's also more complex and expensive to build and maintain. So, diesel-electric or nuclear? Each has its strengths and weaknesses. Diesel-electric submarines are cheaper and quieter, but they can't stay submerged for long. Nuclear submarines can stay under for months and move fast, but they're more expensive and complex. Whether it's diesel, electric, or nuclear, the propulsion system is a marvel of engineering. It's what allows the submarine to move through the water, navigate the depths, and even sneak up on an enemy undetected. Yet, despite their differences, both systems have one thing in common. They allow the submarine to carry out its mission, whether that's scientific research, defense, or exploration. The propulsion system is what drives the submarine, making it an essential part of its design. Navigating underwater and staying in touch with the outside world can be challenging, but submarines have found a way. This is where sonar and periscopes come in, two ingenious systems that have revolutionized underwater navigation and communication. Let's start with sonar. Sonar, or sound navigation and ranging, is a system that uses sound propagation to navigate, communicate with, or detect objects on or under the surface of the water. Submarines emit sound waves that travel underwater until they hit an object. These sound waves then bounce back, and the time it takes for them to return gives an estimate of the object's distance. This allows the submarine to navigate around obstacles, detect other vessels, and even locate underwater landscapes. It's like having an underwater GPS, guiding the submarine through the deep, dark depths of the ocean. Now, let's talk about periscopes. In the early days, periscopes were the eyes of the submarine. They allowed the crew to see what was happening above water while remaining safely submerged. The traditional periscope has evolved though. Now, submarines are equipped with photonic masts, which are essentially high-tech periscopes. These masts use digital cameras to capture images, which are then displayed on screens inside the submarine. But periscopes and their modern counterparts do more than just offer a view of the world above. They're also crucial for communication. Submarines can use their periscopes to access air, enabling them to send and receive radio signals. This is where the concept of a snorkel comes in. The snorkel is a conduit that extends to the surface and enables the submarine to draw in fresh air and expel exhaust gases, all while remaining submerged. So, while the submarine might be isolated in the depths of the ocean, it's never really alone. The crew can navigate safely, detect potential hazards, and stay in touch with the outside world. The sonar paints a picture of the underwater world, and the periscope or snorkel connects the submarine to the surface. Despite being isolated underwater, submarines are never really out of touch thanks to these ingenious systems. Living inside a submarine is no ordinary experience. Let's find out why. Imagine living in a place where space is limited, natural light is non-existent, and the air you breathe and the water you drink are constantly recycled. Welcome to life inside a submarine. The challenges are many, but the human spirit of adaptability and ingenuity always finds a way to make it work. Firstly, space is a precious commodity. The quarters are cramped with every square foot designed to serve multiple purposes. The beds, called bunks or racks, are stacked 3 high in tiny compartments. Personal belongings are stored in a small locker or even inside the mattress of the bed. Despite this, submariners learn to coexist in harmony, respecting each other's space and privacy. Secondly, there's the lack of natural light. Imagine going weeks without seeing the sun. The interior lighting is kept low to conserve energy and mimic a 24-hour day-night cycle. This can affect the body's natural rhythm, but submariners adapt by following a strict schedule and routine. Then there's the matter of air and water. Given that a submarine can stay submerged for months, the supply of fresh air and water is crucial. Sophisticated systems are in place to recycle and purify air and water. Oxygen is generated through electrolysis, removing carbon dioxide from the air. Water is made from seawater through a process called reverse osmosis. These systems ensure that the crew has a constant supply of fresh air to breathe and clean water to drink. Living in a submarine also requires a strong mental fortitude. Submariners often say that it's more of a mental challenge than a physical one. Being cut off from the outside world, living in confined spaces, and working in high-stress conditions require resilience and a strong sense of camaraderie. Despite all these challenges, life inside a submarine is not all hardship. There's a strong sense of community, and many submariners speak of the unique bond they share with their crewmates. It's a life that demands sacrifice and adaptability, but it also fosters resilience, camaraderie, and a deep sense of pride. Life inside a submarine is a testament to human adaptability and ingenuity. So, how does a submarine work? Let's take a moment to revisit our journey. It all begins with the principle of buoyancy, a fundamental force that allows submarines to dive deep into the ocean or rise to the surface. They manipulate this force by using ballast tanks, filling them with water to submerge and emptying them to ascend. Next, we have the propulsion systems, a marvel of engineering that enables these underwater vessels to navigate the vast seascape. Alongside this, we've explored the key communication and navigation systems, including the indispensable snorkel and periscope, linking the submarine to the world above. And who could forget the peek we took into life inside a submarine? It's a testament to human resilience and adaptability, living and working in such confined spaces, far from natural light or fresh air. That's the fascinating world of submarines for you, not just a marvel of engineering, but also a testament to human resilience and adaptability.